We can think about fractions or division in many different ways, but in this video we're going to cover a specific way that's very important to this course. So let's compare the numbers 5 and 2. So I'm going to draw some line segments to represent these values. So we'll represent the value of 5 with this blue horizontal line segment, and then we'll represent the value of 2 using this red horizontal line segment. So we know 5 is larger than 2, so we'll approximate it like this. So if we want to compare these, 5 is actually 2.5 times as large as 2. So 5 is 2.5 times as large as, I'm going to abbreviate this, times as large as 2. So the blue segment looks to be about 2.5 times as long as the red one. Now it also turns out that 5 divided by 2 is equal to 2.5. So notice we have all the same numbers here. So 5 was 2.5 times as large as 2, but 5 divided by 2 is also 2.5. And it turns out, anytime we try to do a similar comparison, or a times as large as comparison, the ratio of those two values, or like the quotient there, actually tells us the answer to that times as large as comparison. So, in general, A is A divided by B times as large as B. And therefore, when we see this A divided by B, a lot of times in this course, we're going to think about that ratio, or that fraction, as telling us the size of A relative to B, or that A is A divided by B times as large as B. This is a very important way of thinking about division, or ratios, or fractions. All right, so let's use this idea in an applied context. Suppose Alex is 61 inches tall, and Joe is 52 inches tall. So maybe we'll represent those using line segments. So this, I'll just say A for Alex's height. We'll use this horizontal line segment to represent that. Maybe that's a little too long, so let's do this. And then we'll represent Joe's height with this red line segment. And we know that this is 61 inches up here, and this is 52 inches down here. So maybe we want to compare these two heights in a times as large as type of way. So we might say Alex's height is more than 1 times as large as Joe's height. But we can actually be very precise about this. We could actually say Alex's height, so I'm just going to say A for Alex's height in inches. Alex's height, is 61 divided by 52 times as large as, I'm going to abbreviate that again, times as large as Joe's height. Right? Alex's height is 61 inches, Joe's height is 52 inches, so Alex's height is 61 divided by 52 times as large as Joe's height. And this actually has a numerical value, if you were to plug that into a calculator, of approximately 1.17, which tells us Alex is about 1.17 times as tall as Joe, which seems to make sense based on our diagram. If we flip things around, we could say that Joe is 52 divided by 61. Her height is 52 divided by 61 times as large as Alex's height. And if we plug this into our calculator and we computed that actual value, it would be approximately 0.85, which would tell us Joe's height is about 0.85 times as large as Alex's height, or that Joe is about 0.85 times as tall as Alex, which makes sense based on our diagram. If we have a number less than 1 telling us the times as large as comparison, then that first thing, Joe's height, is going to be smaller than the second one, which is Alex's height.